Hello, everyone. My name is Tony Grady Rose. My team members are Maurice West, Demaya Budd, and Shayla Gafford. And this is our STEM Fair presentation, the Seaglide Ultrasonic Sensor. So in this slide, we are going to introduce the Seaglide. So with the Seaglide, it is an autonomous drone that travels in the water by shifting its weight on the inside, and allow us to go up and down. So it's not like other drones in which it runs on like technology in which it with rotors and with a vehicle and such, but it actually goes manually, which means that as it travels in the water, it will go up and down with the weight of the electronics on the inside of the Seaglide, and that's how it actually travels in the water with the shift of its weight, making it a lot easier to travel in the water and such. So with the sensors that we're going to be adding onto the Seaglide, we will be able to collect accurate data from it and make a good analysis of the environment around it. So when the Seaglide is in the water, we cannot exactly communicate with it because of how the waves, the ultrasonic waves that we're going to be sending won't be able to go through the water since it will be too dense for it, which means that in order to communicate with the Seaglide will have to be able to reach the surface of the water so we can communicate it again and give it new commands. So in this slide, as you can see, this is the ultrasonic sensor that we're going to be using on the left. It is of a good size, which means that it will be able to collect a lot of data from the environment. And as you can see on the right with the beam pattern, you can see that the waves that the ultrasonic sensor will be emitting will be able to go a good distance away from the Seaglide and be able to get a better view of the environment than other Seaglides. Maurice?
Okay, so my job as the document manager and what's it and CAD designer was to upload the files to Onshape, which is a CAD software. And with that, I brought up the image to the left, which is the Arduino, and the Arduino to the right is the actual one.
And in this image, you can see a better view of the real-life Arduino. Alright, so in this slide, we are going to be going more in depth of the ultrasonic sensor that we are going to be using. So the ultrasonic sensor, the one that we have, as you can see, so you can see the type of ultrasonic sensor that we're going to be using in the first point. And with this Seaglide, it is weather resistant, which means that we'll be able to make it at least find some ways to make it waterproof with the methods that we will do, like the epoxy and sealing openings and so on. So with the weather-resistant ultrasonic sensor, then we will have more options to use it in the water. So with the ultrasonic sensor, of course, since it uses ultrasonic waves, it will be similar to how we'll use echolocation like a bat. So like a bat, the ultrasonic sensor will send out waves in the water, so it'll send out emit waves from the front. So it'll send waves to the front, and once the waves reach an object in the water, then once the waves come back from that object, then the Seaglide will be able to collect the data of what's around on the display, and we'll be able to see how we can maneuver the Seaglide once it gets back up on the surface water. So with that layout, we'll be able to get a better feeling as to what type of environment it is in. All right, Deshayla, would you explain the problems we faced?
Okay, so the problems we faced during completing the project was finding the right ultrasonic sensor to use for underwater purposes and getting epoxy to seal the openings, not receiving the right size rotor and having to get a new one to continue the construction for the Seaglide and figuring out how the waves of the sensor will reach out to the water while protecting the insides of the Seaglide.
All right, in this slide, Demaya will explain the process as to how the construction of the Seaglide underwent.
Okay, so the first step in building a Seaglide was connecting the power supply to the other wires and getting it all connected to the circuit board. And then after that, we had to work on the buoyancy engine, which was basically a weight field plunger. And then the second part was the circuit board, which controls the buoyancy engine. Part four, we had to work on the Arduino circuit board and put all the parts together. Step five was the bottle cap preparation, where we epoxy the bottle cap to make it waterproof so that no water would get into the Seaglide. Step six was actually assembling the buoyancy engine and basically connecting all the parts like the motor and the circuit boards to the cylinder, the weighted cylinder. Step seven was bottle preparation, where we took all the things that we had put together for the buoyancy engine assembly and putting it in the bottle.
So part 8 is something that we're gonna continue to work on next week after doing all the rest of the parts of the steps.
All right, so in this slide, we are going to be explaining the roles that we had to take on so we can complete this project in a effective manner. So as you heard Maurice earlier in this presentation, he is the project documenter, which means that he is responsible for managing all the data that we have made in our notes in OneNote. And it was thanks to OneNote that we were able to keep a detailed list of all the notes that we have taken, like since the start of the project. So with OneNote, we had listed important details that we needed to know, and then that leads to the project manager with those details that we learned in class of the schedules that we needed to keep track of. Then the project manager lists all the important dates and schedules that we need to uphold to as we move along in the process. And with with Team Gantt giving us notifications of when our assignments are due, then that was able to give us a chance to stay on track without having to constantly worry about forgetting a task. And with project construction, it's thanks to the project construction that we were able to build the Seaglide in the first place. And the project construction followed the steps of the seaglide.org. So with the Seaglide instructions on that website, they were able to complete the basic build of the Seaglide and gives us a chance to modify it for when we put the sensor. And speaking of sensors, that's where the project researcher comes in for the final part of the Seaglide project, which is to find which sensors might be possible to work with this Seaglide, and by figuring out which sensor will actually work with the Seaglide, then they'll have to figure it out how they'll utilize that sensor and give it a purpose for the Seaglide so we can innovate it different from other Seaglide models. Alright, so that is the end of our presentation. Thank you for coming.